Good day. I will be presenting research on metals and metalloids in Clinus superciliosus from South African waters. Metals and metalloids can be monitored using bioindicator species such as fish and invertebrates. These species accumulate and can reflect the bioavailability of pollutants within specific habitats. Since fish are usually higher in the food webs, they may accumulate higher concentrations and pose a threat for consumers. Toxicity of these metallic elements are influenced by environmental and biological factors. Different species have different accumulation patterns due to unique abilities of shell formation, sequestration, shedding, and reproduction, to name a few. It is thus important to consider different species from different habitats to better understand metal metabolism in aquatic ecosystems. The highly dynamic South African coastline is lined with two different ocean currents and varying local circulation processes. Cold nutrient-rich water along the west coast flows in a northerly direction via the Benguela current, while warm water flows southwards along the east coast via the Agulhas current. These diverse ocean currents result in high biodiversity and productivity. Anthropogenic activities within 100 meters of the shore pose a great threat to the marine biodiversity. Overexploitation and degradation of resources, habitat destruction, and pollution are the main challenges that contribute to the ocean economy. Pollutants are transported to and accumulated in the marine environment by freshwater runoff, circulation, and different wind patterns. Large-scale monitoring of metal pollution is lacking in South Africa, where reports are limited to the Mussel Watch program and other studies on mussels in harbors. The present study determined the bioaccumulation of selected metals and metalloids along the South African west and south coasts using the Southern African endemic infratidal klipfish Clinus superciliosus as an indicator species. We hypothesized that the proposed indicator will reflect metal bioaccumulation based on their proximity to land use activities. Concentrations of essential and non-essential metals and metalloids were determined in mussel, liver, and fry of Clinus superciliosus, sampled from 6 localities along the South African coast. Influence of intrinsic factors on bioaccumulation were also evaluated. Sampling localities included Langebaan Marina within Saldanha Bay on the west coast of South Africa. This locality is located within a commercial harbour with mussel and oyster aquaculture in the bay. The Cape Town Harbour locality is located within a busy commercial port, and Simonstown Marina with a blue flag status within the Greater False Bay area. Old Harbour Hermanus is used for small-scale fishing activities and contains 2 abalone farms. Tsitsikamma is located within the Garden Route National Park, which is a no-take marine protected area. Sinsa is a small recreational town north of East London and on the east coast of South Africa between 2 marine protected areas. The necessary permits and ethical clearance were obtained prior to sampling. Small baited traps were used to catch Clinus superciliosus, and fish were transported to the field station for dissection. Prior to dissection, fish were identified, photographed, and measured. The condition factor was also determined per fish to establish their response to environmental influences. Mussel, liver, and fry samples were collected and frozen at -20 degrees Celsius for elemental analysis. Liver was selected as it is the main detoxifying and elimination organ following metal uptake, while mussel represents long-term bioaccumulation due to metal sequestration mechanisms. Tissue samples were then undergone moisture content determination followed by freeze-drying and digestion using 4 milliliters sub-boiled 65% nitric acid. Digest were then diluted to a volume of 5 milliliters using molecular water. Multi-elemental analysis using ICP-MS was applied, with yttrium and thulium as internal standards, as well as multiple certified reference materials. Univariate statistical analysis included a normality test where data were normally distributed one-way ANOVA followed by Tukey's multiple comparison test was performed. Where data were not normally distributed, non-parametric Kruskal-Wallis ANOVA was performed, followed by Dunn's multiple comparison test. Significance was set at 0.05. A correlation analysis of the log-transformed concentrations per locality was performed to examine the influence of size on accumulation. However, the results indicated that size had a limited influence on the accumulation, and subsequent statistical analyses were conducted on pooled samples of all sizes at each locality. A principal component analysis was realized to assess the spatial patterns associated with metals and metalloid concentrations, with size and condition factor as supplementary variables. Data were log-transformed, centered, and standardized. The following graphs depict the metal concentrations of muscle on the left and liver on the right y-axis, arranged from west coast on the left to east coast on the right of the x-axis. Unexpected high concentrations on the southeast coast at Titicaca and Sensa for the majority of the elements were found, which can be indicative of long-term exposure to elements due to freshwater input through geogenic weathering and frequent upwelling along this coast. These include cadmium, copper, lead, and zinc, which have a high affinity for organic matter. Concentrations of antimony and tin in muscle tissue were significantly higher at Cape Town Harbour, Simonstown Marina, and Old Harbour Hermanus, respectively. These are, however, only trace amounts, most likely from historic anti-fouling paints used at the busy commercial harbour and the Navy Yard next to the marina. Anti-fouling paints are used as biocide for ship hulls, underwater surfaces, and timber, which greatly elevated anthropogenic tin, copper, and zinc levels in the marine environment. The concentrations in the present study are, however, 35 times lower when compared to polluted harbours in the Baltic Sea. Copper, iron, and lead concentrations in liver tissue were also elevated at Simonstown Marina and identified as possible hotspots from a recent exposure event. When comparing elemental concentrations of Clinus to other studies, squid and sardine from the South Atlantic Ocean revealed higher concentrations and was attributed to upwelling, while croaker from the Muddy Flats and coral reefs from the Persian Gulf had elevated concentrations of cadmium and lead. Clinus had elevated concentrations of essential copper and zinc compared to mudskippers from the Malaysian waters, but low levels of non-essential cadmium and lead. The high concentrations of essential metals in the present study were attributed to the surrounding natural high geogenic sources at Titicaca and Sensa. The overall spatial bioaccumulation pattern showed distinct spatial separation in muscle tissue concentrations between the South Coast and the West Coast localities. An association is evident between the West Coast localities and larger specimens, attributed to the fact that these localities have infratidal habitats. Local physical ocean conditions, such as water movement due to strong tidal sweeps, upwelling, and seasonal wind-driven water movement in bay areas, can also cause depositional zones. Condition factors correspond to the concentrations of metals detected in the present study, where different age classes and habitats can contribute to the variation between localities. Coastal development within 100 meters of the shore is prevalent in the Western Cape, particularly Saldanha, Cape Town, False Bay, and Hermanus, increasing the pressure on natural resources and increasing land-derived pollution sources. Decline in habitat quality and contamination of nursing areas of transient fish can be seen as a result. The data obtained from the present study do not support the hypothesis that metal bioaccumulation will reflect proximity to surrounding land use activities. Size and sex of fish also had no significant influence on elemental bioaccumulation of mussel, liver, and fry of Clinus superciliosus. From the present study, it can be concluded that large-scale oceanographic processes and diffuse sources rather drive concentrations in Clinus and not direct sources of pollution. It might thus be useful to compare these concentrations with those of pelagic fish species to determine larger-scale effects. As seen in the heat map, specific elemental hotspots were attributed to localized land use activities and runoff during the rainy season. The limited data on bioaccumulation patterns of intertidal fish species highlights the need for long-term monitoring, as well as studies on resident and transient fish species, which can contribute to national marine pollution monitoring programs. For more information on the present study, feel free to read the publication in Marine Pollution Bulletin. Thank you to the following persons and institutions for assistance and funding during the project.